I'm Anil Kumar. Welcome to my series on logarithms and exponential functions. In this video, we are going to understand how to sketch graph of exponential functions. To begin with, I've taken two very simple examples. We need to sketch graph of the following exponential functions. A, f of x equals to 2 to the power of x and f of x equals to 2 to the power of x minus 2 on this graph. And B is to sketch the parent function 2 to the power of x along with 2 to the power of minus x. Now, whenever we want to sketch any graph, we have to always look into key points. Now, what are key points for an exponential function? This is what you need to understand. We are looking for at least 5 key points. The key points will include the x values as minus 2, minus 1, 0, 1, and 2. And also what happens when x is very large, negative, and positive value. We can actually place it in a table, right? So let me just in between construct a table. We'll take some values for x and we'll evaluate what is f of x. So f of x, well, it could be either one. So we'll first evaluate what is f of x equals to 2 to the power of x. And the other function will use transformation to find the result, right? Okay. Now, if x is 0, let's say, if x is 0, in that case, we have 2 to the power of 0. And you know, anything to the power of 0 is 1. So we get a coordinate point which will be 0, 1, right? If x is 1, then we get 2 to the power of 1, which is 2. So on the Cartesian plane, we get a point which is 1, 2. And if x is 2, then we get 2 to the power of 2, which is 4. And the point corresponding to this will be 2, 4 on the Cartesian plane. We could have taken minus 1 and minus 2 also. So 2 to the power of minus 1 is half and 2 to the power of minus 2 is 1 by 4. So that gives you the Cartesian points minus 1 half and minus 2 1 by 4. You notice all of them are positive. Now another key feature is what happens when x is approaching negative infinite value. Well, if that happens, then we are dividing by a very large number, and therefore y also approaches a value which is very small, and the small value is almost 0. Since we are approaching from the positive side, I'm writing this positive number here. Now what happens if I have x value very large, right? So in that case, the y value will also be very large, so it will be infinitely large. So that actually gives you end behavior, right? So this is what we call as end behavior. So end behavior is also a very important feature whenever we are sketching any graph. So with these points, we can at least sketch 2 to the power of x, right? So since most of the values are positive, let me take a line, horizontal line along slightly here, and then we'll take a vertical line like this. When we say sketch, it is kind of a rough sketch. When it is plot a graph, you should be very careful. You should use ruler and draw smooth curves, right? Now, the points given to us are, let's begin with this at 0. The y-intercept here is right there, correct? And then at 1, we have a point 2. At 2, we have a point 4, right? So that, and then when it is minus 1, we have half. At minus 2, 1/4. And we know it is approaching negatively like this on this side. It is approaching 0, right? As you approach negative infinity towards x, and on the right side it is approaching infinitely large value. Right? So kind of like this. That gives you the graph for the function f of x equals to 2 to the power of x. Clear? Okay. Now let's try to figure out how to sketch the second graph, which is 2 to the power of x minus 2. Okay. So let me take another ink to sketch that graph. So we'll use green color for this. Now this means what? Here 2 to the power of x minus 2 really means that we have to translate 2 units right. So that means this function is translated to right. That is what it means. So what we can do here is that these critical points, we can just push them 2 units right. So that comes here, this goes 2 units right, this goes 2 units right, this goes 2 units right, that goes 2 unit rights, and we have our graph. So now we have a graph which is kind of like this. So this corresponds to our translated function. Is that clear to you? Perfect. So that is the way to sketch the exponential function. Let me write f of x here. So we have both the graphs on the same graph, and you can see how it works. So basically, every point here has been moved 2 units to the right. That is what it is. Now let us try to sketch the other function, which is the base function. We can use these values, and this is 2 to the power of minus x. What does that mean? It means the reflection, right? This means what? This 2 to the power of minus x means reflect which side? You need to reflect the graph of 2 to the power of x on this is horizontally reflected on the y-axis, right? So on the y-axis. That is how it is going to be. So let's do it. This time I'm going to draw it more symmetrical. So we have the y-axis right in the center. Since we are going to reflect it on this, let's keep the horizontal slightly below as we did earlier. And the original graph of 2 to the power of x will take these points. So we have these points here, right? And then this is this. So we have a graph of 2 to the power of x. So this is 2 to the power of x, correct? Now since we are reflecting it, it comes on the other side. So let me just the point here is called the invariant point. It is going to remain there only. This point gets reflected, it comes here. This point gets reflected, comes here. And these go on the other side. Do you see that part? Right. So what we have is a graph which is now approaching in this direction. For positively infinite value of x, it approaches 0, right? So it becomes, earlier it was always increasing, now it becomes always decreasing, right? Do you see that part? So that is how the graph is going to be, right? So let me just connect this. So that becomes our graph for 2 to the power of minus x. So as you can see, the nature changes. So it becomes always decreasing from always increasing, right? So in short, that is how we could actually plot the graph of our transformed function. I hope with this you have a clear idea of how to sketch exponential functions. You can translate these up and down, and now I'd like you to try out some of the graphs. Let's say C and D. So D will just do a transformation here. Let's say f of x is equal to 2 to the power of minus x minus 3. So in that case, all these points will come 3 units down, right? The horizontal asymptote, which is y equals to 0, let me write down here, this is called the horizontal asymptote. it is y equals to 0 in both these graphs. But when we translate it up and down, the horizontal asymptote will change, right? So this will have a horizontal asymptote, which is going to be y equals to minus 3. So try to sketch this graph, and you can also try a sketching graph for the function. Let me vertically stretch this also. So we could have 3 times 2 to the power of, let's say, x minus 2. So in that case, you can vertically stretch each point and then draw the next graph, which will have a vertical stretch. So if you do that, you will understand how do we incorporate vertical stretches and compressions and vertical translations, right? So I hope that makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.